Hey everyone, and welcome. Today we have an incredibly fascinating explainer that bridges two worlds you might never have thought to put together. We're talking organic biology and the bleeding edge of digital network theory. We are going to dig into the striking parallels between the natural, ruthless efficiency of organic mycelial networks and a revolutionary Layer 1 blockchain protocol known as Saito. If you're a mycology nerd, or if you're just absolutely fascinated by how decentralized systems scale, you are going to love this one.
I know, it sounds like a totally wild question, right? What can underground fungi really teach us about the future of the internet? But as we peel back the layers of our current digital infrastructure, we actually find that nature solved our most complex routing and scaling problems millions of years ago.
Let's dive right into Section 1, Nature's Perfect Network. So, let's start with the biological blueprint. Beneath the forest floor lies the mycelial network. It's nature's original, highly adaptive, and completely decentralized mesh architecture. It shares resources, processes information, and optimizes its pathways for the survival of the entire ecosystem. And it does all this without a central brain. If we map this biological foundation directly to the digital world, it lines up perfectly. You have the mycelial network acting as the base. Then, moving up a level, you have the protocol layer, which is the Saito consensus mechanism, a digital system mimicking that exact organic efficiency. And finally, we have the physical interface, things like soil moisture sensor nodes. These physical nodes act just like fungal tips, feeding real-world environmental data right back into the digital protocol.
When you look at how a decentralized mesh architecture branches out, it's brilliant. It perfectly reflects those organic mycelium threads efficiently distributing nutrients. In the digital world, these nodes are routing transaction data instead of nitrogen or phosphorus, sure. But the fundamental geometry and the strict requirement for highly efficient cooperative sharing is exactly the same.
Moving on to Section 2, the blockchain disease.
Here's the harsh reality. Our current digital networks are sick. Traditional blockchains suffer from afflictions that are remarkably akin to parasitic hoarding. Older proof-of-work and proof-of-stake systems pay the miners or the stakers, but they dramatically underfund the user-facing nodes, the actual infrastructure that makes the network usable. This creates what economists call a tragedy of the commons, along with a massive free rider issue. Think of it like a parasitic organism draining its host. Everyone wants to use the network, absolutely, but nobody actually wants to pay to maintain the public infrastructure. Over time, this leads directly to blockchain bloat and a system that literally chokes on its own data.
The ultimate fatal symptom of this disease is known as the infura problem. Because volunteer nodes simply can't afford to run the network out of pocket anymore, public blockchains are quietly mutating into permissioned networks, dominated by monopolies. A few massive, centralized companies end up controlling the vital choke points where users actually access the blockchain, which completely defeats the entire purpose of decentralization in the first place.
Which brings us to Section 3, Proof of Routing Work.
So, how do we cure this network disease? Well, we look back to nature. Saito introduces a really elegant solution called proof of routing work. Instead of paying nodes simply for burning electricity or hoarding tokens, Saito pays nodes for the actual value they deliver to the users, which is collecting and sharing transactions. The network actively rewards cooperation and efficient sharing, naturally starving out nodes that try to hoard data or act like parasites.
Let's break down how this functions step by step. First, a user sends a transaction. Second, a routing node ticks it. But here's the kicker. As it passes the transaction along, the routing work is halved with every single network hop. It's an ingenious mathematical decay. Finally, the block producer secures the chain. This behaves exactly like a fungal network routing nutrients. It mathematically forces the entire network to find the absolute shortest, most efficient, and most open pathways to share resources. By acting as a truly open infrastructure layer, Saito connects web clients and IoT devices seamlessly. Because the nodes are being paid directly to route data, developers can run applications right there in the browser. You don't need centralized servers, and you don't need centralized APIs. The network organically funds its own access points.
Now for Section 4, the golden ticket.
Any healthy organism needs self-regulating fruiting bodies to prevent runaway growth or inflation. Enter the golden ticket. When a block is produced in Saito, the fees aren't just blindly handed out. The network actually has to solve a cryptographic puzzle to unlock and fairly divide these fees between the block producers and the routing nodes. What's absolutely brilliant here is that this mathematical puzzle ensures an attacker can never, ever extract more money from the blockchain than they spend to attack it. It completely secures the ecosystem, acting just like a biological immune system.
And just as a forest relies on a natural composting system to deal with dead wood, Saito has automatic transaction rebroadcasting, or ATR. This is a dynamic rent and pruning system. Instead of storing every single piece of data forever, which is what causes that massive bloat we talked about earlier, old transactions actually have to pay a fee to stay on the chain. If they don't, they are naturally pruned or composted away. It keeps the blockchain infinitely sustainable.
All of these mechanics create a continuous, cyclical flow within the Saito token economy. The application pays the transaction fees, the block producers collect them, and then they're distributed right back out to the security providers and routing nodes. It's a completely closed, self-sustaining economic loop. It totally eliminates the need to rely on those external, centralized monopolies for funding.
Which leads us to our final part, Section 5, a self-optimizing ecosystem.
When you put all these mechanics together, you realize you no longer just have a piece of software. It's a perfect synthesis. We take the mycelial blueprint for decentralized sharing, we execute it through the Saito consensus protocol, and we can even hook it up directly to the real world. By integrating things like physical soil moisture sensor nodes, we effectively bridge real-world environmental data directly with that decentralized protocol layer. We're creating a living, breathing digital network that actively responds to physical inputs.
And this brings us to a really critical realization. Because the nodes and the users share the exact same incentives, optimizing network rewards automatically optimizes the user experience. You don't have to choose between a fast network and a secure network anymore. In Saito, scale and security are the exact same metric. As the network grows, it inherently, automatically becomes more secure. There's a great quote from our source material that really hits the nail on the head here. It says, "By basing compensation on the actual value delivered, Saito guarantees the sustainability and economic independence of an open network." It essentially proves that the long-feared blockchain scalability trilemma, that stubborn idea that you always have to sacrifice decentralization to get speed, well, it simply does not exist if you align your economic incentives with the laws of nature.
I want to leave you with this provocative thought to chew on. If nature has already perfected this scalable, decentralized network over millions of years of evolution, why on earth are we still paying centralized digital monopolies to run ours? It's time to fundamentally rethink the architecture of our digital world. And perhaps it's time to take a few more notes from the ground right beneath our feet. Thank you so much for joining me for this explainer, and as always, keep questioning the systems around you.